Hello, my name is William Stewart. I'm an applications engineer working in the automotive products group within Microchip Technology, and today I'll demonstrate the Microchip CAN BUS analyzer. The CAN BUS analyzer is a low-cost tool used for debugging high-speed CAN networks. The tool offers some functionality found on higher-end tools such as input and output triggers and software-controllable termination resistance. The tool also provides some visual indications to give a user a quick view of the bus status, such as CAN error LED. This CAN error LED shows green under normal error conditions, or turns yellow under error passive conditions, or red in CAN BUS off. And the CAN TX and CAN RX LEDs will flash when the transmission or reception of CAN messages. The analyzer also has two screw terminals. This first screw terminal provides a pass-through through the CAN bus. This allows the user to probe the bus without modifying the wire harness just for a scope connection. This terminal also allows the user to view digital CAN signals. The second screw terminal provides the user with trigger input and output connections. This allows the user to connect to a scope, and when a certain CAN message is received on the bus, the analyzer will then trigger the scope with a pulse. The tool also can be powered through 9-volt connection or USB connection. Here, this setup here, the CAN BUS analyzer is powered by the USB. Today's demonstration will show the tool analyzing a simple CAN network. This CAN network will consist of two nodes, one being the Microchip CAN BUS analyzer, and the other being the Explorer 16 demo board with a DS-PIC33F and an ECAN LAN pigtail daughter board. The Explorer 16 demo board is set up to transmit CAN messages from an internal table. The CAN BUS analyzer GUI will show the incoming messages from the Explorer 16 board either in a rolling trace window that shows that messages received in a sequential order, or a fixed trace window that shows the messages received locked in an ID. In either case, the GUI will show the ID, the data length code, and the data, the timestamp associated with that message, and the time delta. The GUI also provides a way for transmitting messages on the bus. This is a very clean window for transmitting a message. In the example here, I'm going to transmit ID 11, data length code 5, and now we need to enter in the data. This window allows you to transmit messages out 3 different ways. Either a single shot message, which would require you to enter in a 0 for the period and a 0 for the repeat, or you can transmit out a periodic message, which would require you to enter a value in for the period, or you can transmit out a message that's sent out periodically but only has a certain number of messages, so you enter in a repeat number. So in this case, if I enter in a repeat of 5, you would see this message ID 11 transmitted out 5 times with a period of 100 milliseconds. For our demo, we'll just transmit out a single shot message. Now if I pause the trace window and scroll down on the rolling trace, you'll see that our message was sent out, ID 11, data length code 5, our data, the timestamp it was sent out, and the time delta with the previous message. Also in the fixed trace window, you'll see that the message ID 11 was sent out with data length code 5, the data. And in this case, the time delta is 0 because this is the first occurrence of this message. Thank you for taking this time to view the quick demo on the Microchip CAN BUS analyzer. To learn more about this tool or to see other Microchip CAN products, please visit www.microchip.com/CAN.